What is up, guys? Welcome to Barton. My name is Heinrich, and today we're going to take a look at 3 different states. We'll look at our wall slide state, our wall grab state, and finally our wall climb state. This is going to get us ready to move on to our wall jump state in the next part. So before we jump into Unity, let's just talk a little bit about the logic and see what's going on. So of course we're going to have our wall slide state, our wall grab state, and our wall climb state. All of these are children of our touching wall state. So for our wall slide state, we're going to transition to this if we're not grounded and we're giving X input towards a wall that we're touching. This will cause us to go into the wall slide animation and just slow our Y velocity down. So seeing as one of the requirements for wall slide is that we're not grounded, that means we can only transition to this state from our in-air state. After that, we have our wall grab state, which is just a state where we stop the velocity of the player on a certain point on the wall. And so we can transition to this from our in-air state or from our grounded state if we're standing next to a wall. So if we give grab input, we'll grab onto the wall. After our wall grab state, we have our wall climb state. And this is just if we're grabbing the wall and we give a positive Y input, we'll climb the wall. As you can see, if we're grabbing the wall and we give negative Y input, we also go to our wall slide state. So that's what we're going to be working on today. Let's go ahead and jump into Unity. Okay, so to get started, let's head to our scripts folder, player states folder, and then let's go ahead and go to our super states and create our touching wall state. So right click, create, new C# script, and we'll just call it player touching wall state. We can then go ahead and open that up. And before we do anything here, let's go ahead and create our other 3 states. So let's come to our substates folder. Let's create a new C# script. The first one is our player wall slide state. Next, we have our player wall grab state. So player wall grab state. And then finally, we have our player wall climb state. Like that. We can go ahead and open up all 3 of these as well. So player wall climb, player wall grab, and player wall slide. Perfect. Okay, so let's just get the basic state stuff that we have to set up out of the way. So we can go ahead and delete all of our pre-generated code. And our player wall slide state is a child state of touching wall. So let's actually first go and set up our touching wall state. Get rid of this. And then we'll just make it inherit from player state. And then we generate the constructor. So quick actions in refactoring, generate constructor. Let's save that and then go back to our player wall slide state. So we'll make this inherit from player touching wall state. And then go ahead and generate the constructor. Save that. Next is our player wall grab state. So we can delete this, then make it inherit from player touching wall state and generate the constructor. And then finally, we have our player wall climb state. So again, delete this code and then make it inherit from player touching wall state and generate the constructor. Perfect, so now all of these are ready to be states. The next thing we can do is set up the objects in our player class. So let's go ahead and open that up. So that's under our player finite state machine folder, player. So let's go ahead and open up the state variables region. And we have 3 new states. So the first one is going to be public player wall slide state. And we'll just call it wall slide state. And then of course we give it a public getter and a private setter. Then next we have our player wall grab state. So public player wall grab, and we'll just call it wall grab state. Then give it a public getter and a private setter. And then finally we have our player wall climb state. So public player wall climb state, and we just call it wall climb state. Now we can go ahead and create the objects in our awake function. So let's minimize our state variables and open up our Unity callback functions. So the first one is our wall slide state equals a new player wall slide state. And we'll pass this as the player, state machine as the state machine, player data as the player data. And then finally our animation boolean name is going to be wall slide, lowercase w. And then next we have our wall grab state. So we'll set this equal to a new player wall grab state with this as the player, state machine as the state machine, player data as the player data, And then finally, our animation boolean name is just going to be wall grab. Again, with a lowercase w, uppercase G. Finally, we have our wall climb state. So wall climb state equals a new player wall climb state with this as our player, state machine as our state machine, player data as our player data. And then finally, our animation boolean name is just going to be a wall climb. Just like that. And now we have all of our states set up. Okay, so the first state we're going to work on is our wall slide state. Now, to know if we should be wall sliding or not, we need to know if we are detecting a wall. So let's go ahead and set up our wall check. If we go ahead and go back to Unity and take a look at our old player, you can see we have this wall check child game object that is just at the position 0, 0, 0. So let's go ahead and click on our player and create a new empty game object. Let's just call it wall check. And we can just leave the transform as is. It's in the right place. So that's like in the middle of our player over here. Next, we need to go ahead and set up our wall check distance in our player data script. So let's go ahead and open that up. And then underneath our check variables, let's just create another public float. And we'll just call it wall check distance. And by default, let's set it equal to 0.5. Just like that. Now we can come back to our player script. And under our check transforms, let's open that up and create another serialized field, private transform, and we'll just call it wall check. We can go ahead and close down our check transforms and our Unity callback functions. And so now we need to create a function that we can call to check if there is a wall or not. So let's open up our check functions, and underneath check if grounded, let's create another public bool. And let's just call it check if touching wall, like that. And then all we have to do in this function is return physics2d dot raycast. And for this raycast, our origin is wallcheck dot position. Our direction is going to be vector2 dot right multiplied with our facing direction. And then next, our distance is going to be player data dot wallcheck distance. And then finally, our layer mask is player data dot what is ground. And now we have a function that tells us if we're touching a wall or not. Perfect. Okay, so now let's set up our transition from our in-air state to our wall slide state. So you can see the condition is touching wall, and our X input is at the wall, and our Y velocity is less than 0. So let's go ahead and open up our player in-air state. So player states, substates, player in air state. And so the first thing we need to do is create another private bool that is going to be is touching wall. And then we can come to our do checks and add that in there. So is touching wall equals player dot check if touching wall, like that. Now we just need to come to our logic update function, and we'll create another else if. So else if, and the conditions inside of this else if is going to be is touching wall and X input equals player dot facing direction. So our wall check is returning true, and the X input that we're giving is in the direction of the wall. So if this is the case, then we're going to just transition to our wall slide state. So we'll say state machine dot change state to player dot wall slide state. Just like that. So now once we're in our wall slide state, all we need to do is limit our Y velocity. So before we can do anything here, let's go ahead and come back to our player data, and let's create a new header for our wall slide state. So header wall slide state. And then underneath this header, we'll just say public float wall slide velocity. And by default, let's just set that equal to 3. Now we can come to our player wall slide state, and let's generate our overrides. So in this case, we really only want our logic update function, so we can just go ahead and deselect all, select logic update, click OK. And then in here, all we need to do is say player.set velocity y, and the velocity we want to set it to is going to be player data dot wall slide velocity. And it should actually be negative this, seeing as we're going down, so we can just put a negative at the front. Now the only thing we have left to do inside of the state is check for our grab input, but we'll get to that in a little bit. So for now, we need to work on our transitions out of our wall slide state. So you can see we have this transition going from our touching wall state to our idle state. And this happens if we detect ground or we don't have a grab input. Otherwise, we also have this transition going to our in-air state. And that happens if we're not touching a wall, or we're no longer giving X input, or we're not giving grab input, and we're not detecting ground. So our transition from wall slide state back to our in-air state comes from our touching wall state. So that's what we're going to work on next. So let's go ahead and go there. So let's first go ahead and generate all of our overrides. Generate overrides. And we just don't want the first three. So again, really, we don't need all of these. But for our bigger states, I like just having all of them in there just so that I don't have to come back later and generate them again. So the first thing we need to do is do our checks. So we want to know if we're touching a wall, we want to know if we are grounded or not, and we also want to know what our X input is. So let's go ahead and declare variables for all three of those. So first we have a protected bool, and we'll just call it isGrounded. Next we have our isTouchingWall. So protected bool isTouchingWall. And then next we just need to read in our X input. So protected int, and just call it X input. And now we can go ahead and add this to our do checks. So the first one is isGrounded equals player dot check if grounded. And then isTouchingWall equals player dot check if touching wall. And then X input we put in our logic update function. So X input equals player dot input handler dot normalized input X. Okay, so let's first work on our transitions to our idle state. So we can go ahead and say if isGrounded, and then we also have to add our grab input here, but we don't have that yet. So we'll just open up our if statement, and then in here we just say state machine dot change state to player dot idle state. Then next we have our transition to our in-air state, which again is we're not touching wall, we don't have X input, and actually this X input over here is wrong. It should be we either don't have X input or the X input is away from the wall. And then finally, we're not grounded, which in this case we don't really have to add there, seeing as we already have isGrounded over here. So we can just say else if not isTouchingWall or X input does not equal player dot facing direction. So in this case, if X input is 0 or -1, if the wall is on our right, we will trigger this transition. So in here, we just say state machine dot change state to player dot in air state. And so we're actually ready to test out our wall slide. So let's go ahead and go back to Unity. And then we just need to create our wall slide animation. So let's open up our animation window and then come to our sprites folder, player, and open up our character. So our wall slide animation is currently set up for sprites 17 to 21, but these are all just the same sprite. I just put them all there because I'm still planning on adding some more animations to that later. So we can just use the first sprite. So let's go ahead and click on our player and then create a new animation. Navigate to our animations folder, player, and then we'll just call it wall slide. We can then go ahead and drag in our sprite, and seeing as we only have one, we can just leave the sample rate at 60, and that's good. So we can go ahead and close down our animation window, and then let's come up to our animator. And the first thing we need to do is create our new Boolean parameter that is just called wall slide with a lowercase w. Go ahead and drag that to the top, and then let's position our wall slide animation, and then make a transition from entry to wall slide. Click on it, and the condition this time is wall slide is true. Then we can make a transition from wall slide to exit. Click on that, untick has exit time. Underneath settings, we can change our transition duration to 0, and then add the conditions that wall slide must be false. So just in case you're wondering why I keep dragging the new parameters up to the top, it's just so that it's the default parameter that gets added when I create a new condition. Just saves an extra step. Perfect, so let's give this a try. Let's just quickly click on our player. I think we need to add our wall check transform. Let's not forget that. And yeah, let's see if it works. So if we run up to a wall, yes, you can see we transition to a wall slide, except if we try jumping, we immediately transition to a wall slide. Okay, so let's go back to our scripts and let's come to our player in air state. So currently we're transitioning to our wall slide state if we're touching a wall and our X input is towards the wall, but we also need to make sure that our Y velocity is less than or equal to 0. So just go ahead and add another and we'll just say player dot current velocity dot Y is less than or equal to 0. Let's go ahead and try it out now. Perfect. As you can see, if we're falling down, we start sliding. And we can also play around with our wall slide velocity. It feels like it's a little bit too fast for me. So let's set that to 2 instead. That's better. Okay. And of course now you could add like little particle effects, whatever you want. We actually also need to test out our transition back to idle. Yep. So as you can see, when we touch the ground, we transition to idle, but because we're giving a X input, we transition to our move state. Perfect, so everything works. So now we're gonna go ahead and work on our wall grab state. So the first thing we need to do is add a new input. So let's come back to our player folder, input folder, and then open up our player actions asset. I'm just gonna go ahead and dock that up here again. Okay, so currently we have our movement and our jump actions. So let's create a new action. And this one we'll just call grab. In this case, our action type is going to stay button. And let's click on the first binding. And then let's set that to control on keyboard. And don't forget to tick keyboard as our control scheme. And let's go ahead and add a new binding. And then click on path, listen. And for controller, I'm going to use right trigger. So again, we have the two options. We're going to choose the gamepad option. And then make sure we tick gamepad. And now we have our new grab input set up. So now we just need to create a function for it in our input handler. So we don't currently have that open. Let's open that up and let's scroll down. Underneath our onJump input, let's create a new function. It's going to be public void. And we'll just call it onGrabInput. And then of course our input parameter is going to be input action dot callback context. And we'll just call it context. And this function is going to be very simple. All we're going to do is on context started, we set our grab input to true, and on cancelled, we set it to false. So let's actually go up to our variables and create that Boolean. So we need a public bool, call it grab input. And then of course, give it a getter and a private setter. And then in our onGrab input function, we'll just say if context.started. Then we set grab input equals true. And then if context.cancelled, we just set grab input to false. So of course, once we start holding the button, it gets set to true. And when we let go, it gets set to false. So that's it for the input handler for now. Now we just need to come back to Unity and then click on our player and then come to our player input component and then open up our events, gameplay, and now we have this new grab callback. So let's go ahead and add to our list. And the object is going to be our player input handler. And the function we're going to call is under player input handler, and it's the onGrab input. Okay, so that's everything set up for this. So now let's set up the transitions to our wall grab state. So we have two transitions in there. One is from our grounded state. So in this case, if we are touching a wall and we do give a grab input, we transition to our wall grab state. And the other one is from our in air state, which is basically the same condition. So if is touching wall and grab input. Okay, so let's start with our grounded state. Do we have that open? We do not. So let's go ahead and open up our player grounded state. And the first thing we need to do is add our is touching wall. So we have a private bool is touching wall. And then we just have to go ahead and add that to our checks. So is touching wall equals player dot check if touching wall. We then also need to read in our grab input. So let's create another private boolean, call it grab input. and then we'll come to our logic update function. So after we read in our X input and our jump input, we'll say grab input equals player dot input handler dot grab input. Then we can come and create another else if, and the conditions for this else if is touching wall and grab input. Then inside the function, all we say is state machine dot change state to player dot wall grab state. Then let's come to our player in air state. So we already have our is touching wall boolean. Now we just need to read our grab input. So private bool, call it grab input. And I just realized in my player grounded state, I spelled grab input with a capital G. So let's just go ahead and fix that. Lowercase g, perfect. Okay, back in our player in air state, let's go ahead and read in the input in our logic update. So after we read in this input, we'll just say grab input equals player dot input handler dot grab input. Then after this, we can create another else if, but now let's think about it. We want to transition to our wall grab state to be more important than our wall slide state. So we'll put this else if in front of this wall slide transition. So that way we'll transition to our wall grab state if we happen to be holding down the grab button and input towards the wall at the same time. So let's open up this else if, and the condition is touching wall and grab input. Like that. Then inside this else if, we just say state machine dot change state to player dot wall grab state. So let's go ahead and take a look at the state machine diagram. So we have these two transitions set up, so now we can work on our wall grab state. So in this case, it looks like we're going to read in our Y input, and then based on that, we'll either transition to our wall climb state, or we'll transition to our wall slide state. So let's go ahead and take a look at that. Let's come to our player wall grab state, and then let's generate our overrides. Just like that. And so actually, as you can see, we need to read in our Y input in our wall grab state and our wall climb state, because based on that, we transition between the two. So we might as well just write the code to read in the Y input in our touching wall state. So let's actually go ahead and do that first. Let's come to player touching wall state. Let's declare another protected int, call it Y input, and then just add that to our logic update function. So after we read an X input, we'll say Y input equals player dot input handler dot normalized input Y. Now back in our player wall grab state, this state is actually super simple as well. We can come to our logic update function, and then all we need to do here is we'll say player dot set velocity X to 0, and then player dot set velocity Y to 0. So we're effectively freezing the character in place. Next, we just need to set up our transitions. So we'll say if Y input is greater than 0, so we're pushing W or holding up on the left stick, then state machine dot change state to player dot wall climb state. So if we're grabbing the wall and we give a positive Y input, we'll start climbing the wall. And then now if we give a negative Y input, we should wall slide. So we'll say else if Y input is less than 0, and so we're saying less than 0 and not less than or equal to 0, because if we're not giving any Y input, we just want to stay in our grab state. So after this, we'll say or not grab input. But I just realized we're not actually reading in our grab input. So let's just go to our player touching wall state, and let's add that as well. So protected bool, and again, just call it grab input. And let's just move that up to the other bools. And so in case you didn't know this, if you hold Alt and then use the up or down arrow keys, you can move lines around. Okay, let's go to our logic update function. And after read in our X and Y input, we'll say grab input equals player dot input handler dot grab input. So that should fix it in our player wall grab state. Yes. So else if, and then in this case, we just say state machine dot change state to player dot wall slide state. Perfect, so all of that is almost working. The last thing we need to work on is our player wall climb state. And this state is also really simple. In our player wall grab state, we actually only needed to generate our logic update function. We don't really need the rest of these, but we'll just leave it there for now. So in our player wall climb state, we can generate overrides. And in this case, we also only need our logic update function. So let's generate that. And then all we need to do in here is set our y velocity to a wall climb velocity. So let's come to player data and let's create another header. And the title for this header is going to be wall climb state. And then we just declare a public float and we'll just call it wall climb velocity. And by default, let's set this to 3 as well. And then we can come back to our player wall climb state. And then in our logic update function, we just say player dot set velocity y to player data dot wall climb velocity. And then next, we just need to set up the transition back to our wall grab state. So we'll say if y input does not equal 1, so it's either going to be 0 or -1, then in this case, state machine dot change state to player dot wall grab state. And that should be all of that set up. So let's go back to Unity and set up our animations. So we can bring up our animation window, click on our player, and let's create a new animation clip. We just have to navigate back to our animations folder, player. Okay, so our first animation is going to be our wall grab animation. So we'll just call it wall grab. And then our next animation is going to be our wall climb animation. Then we can go to our sprites folder, player folder, and the sprites we use for our wall climb is, it looks like it's sprite 55 to sprite 66. So let's start with the wall climb animation. Let's just drag that in there. If we play it, of course, the sample rate of 60 is too much. So let's change that to 15. That works. It might be a bit fast. Let's try 10. I did not click enter. That looks a bit better. Nobody climbs a wall that fast. Cool, so that's our wall climb animation. Now for our wall grab animation, we'll just use the first sprite from our wall climb animation. So that is sprite 55. We can just go ahead and drag that in there. And of course, he's just going to hold this position. So in this case, it's just 1 frame, so the sample rate does not matter. Next, we can go ahead and go to our animator and set up our animation transitions. We can also close out of our animation window. And here we have our wall grab and our wall climb animations. So now we need to go ahead and create our 2 new Boolean parameters. The first one is going to be our wall grab. And let's just move that up and set up the transitions. So from entry, we'd make a transition to wall grab. Click on that, add a new condition, and the condition is wall grab is true. Then make a transition from wall grab to exit. Click on that, make sure we untick has exit time, set the transition duration to 0, and for conditions, wall grab is false. Our next parameter is our wall climb, so another Boolean called wall climb. Go ahead and drag that up to the top, make a transition from entry to wall climb, click on that. Add a new condition, wall climb is true, then make a transition from wall climb to exit, click on that, untick has exit time, and set the transition duration to 0. So I think we're ready to run this now. Let's see what happens. So if we run against a wall and we hold control, we're transitioning quickly between our grab and grounded state. So that is because we forgot a condition in our player touching wall state. So actually, if we just take a look at our state machine diagram, you can see that to go to our idle state, it's ground detected and not grab input. But we didn't have our grab input yet when we set this up. So currently it's only is grounded. So let's just go ahead and add not grab input like that. Okay, so let's go ahead and try it again. If we run up against the wall, it looks like there's a lot of stuff that I forgot, but it only seems to happen when we're climbing. Oh, what is happening? What did I miss? Okay, so it looks like I didn't add a condition to the transition from wall climb to exit, so don't forget to do that. Add a condition, wall climb must be false. Okay, perfect. We also need to add the grab input to our transition to our in-air state. So currently we're saying if not is touching wall or our X input does not equal player facing direction. So over here we want to add a bracket in front of our X input part and one after that. And then inside the bracket we'll say and not grab input. So we'll only transition to our in-air state if we're either not touching a wall and both of these are true. So we're either giving X input away from the wall and we're not holding the grab input. So let's go ahead and try this now. Fingers crossed I didn't forget anything else. So, don't forget to save, and then let's try this again. Okay, perfect. So if we run up to a wall and we hold control, you can see we go into the grab state. If we hold W, we start climbing the wall. If we let go of W, we start sliding down. Why are we sliding down? But if we hold S, we go into the actual slide state. So why are we not holding position in our grab state? Okay, so I actually forgot something really important in our player wall grab state. So setting our X and Y velocity to 0 is not enough because we set the velocity to 0 and then our physics update happens and gravity starts adding a negative Y velocity. So that's why we keep sliding down a little bit. So what we also need to do is track what the position is when we enter this state and then just keep resetting our player position to that. The reason we set the X and Y velocity to 0, 0 is to keep the camera centered on our player. So let's actually quickly do that. So instead of setting our X and Y velocity to 0, let's create a new function and we'll just call it private hold position. And that should be private void hold position. And then let's just move this set velocity functions in there. And now let's go back up to the top and let's declare a new variable that is going to be a private vector2, and we'll just call it hold position. Then in our enter function, we'll say hold position equals player.transform.position. So the moment we enter the state, we say, okay, what is our current position? And this is now going to be the position where we hold the player. Then let's come to our hold position function. And before we set the velocity, let's just say player.transform.position equals hold position. Perfect. Now we just need to call hold position from our logic update function. And then we also need to call it in our enter function. Like that. Don't forget your semicolons. Okay, so let's try it out again. So now when we climb up, you can see if we let go of W, our character stays where he is and he doesn't slide down. Let me show you what happens if we remove this player.setVelocity xy. Well, X doesn't matter, but let's just comment out the Y one. So let's save that and let's try it out again. As you can see, our camera starts drifting down. That's because our Cinemachine camera works with the velocity of the game object that he follows. So I don't quite understand exactly what's happening, but that's what I can imagine is happening. So by setting our Y velocity to 0, let's actually open up our camera. So you can see this yellow dot. You can see the yellow dot's moving down and the camera is busy tracking that dot. But if we set our Y velocity to 0, and we jump up against the wall, you can see the yellow dot stays where it is. And our camera tracks our player perfectly. Cool, so now we can walk up the wall. Let's try that with controller so we don't get that annoying error. So if we hold right trigger and up on the left stick, we climb. If we hold down, we start sliding. Okay, we don't have a transition going from our sliding animation back to our wall grab animation, or state, sorry. So let's go ahead and take a look at that. So in our player wall slide state, yep, we forgot to set up this transition. This is where to-dos come in handy, guys. So all we have to do here is say if grab input and our y input is equal to 0, then we transition to our wall grab state. So state machine dot change state to player dot wall grab state. So let's try that out again. If we hold up, we climb. If we hold down, we slide. And if we let go of down, we stop. Perfect. Of course, if we let go of the grab button, we drop. And if we give a X input towards the wall, we slide. That's awesome. Okay, so currently we wall slide if we give a X input from our grab state. Oh, I know why that is. So if we do this with keyboard and mouse, so if we walk up a little bit and we're in our grab input and we hold D, we don't start sliding. But if we push right on the controller, we do start sliding. Let's try that again. Well, we either start sliding or we start climbing. And that is because of our normalized X and Y input. If we go ahead and take a look at our player input handler, so input, player input handler, and we come to our onMove input, you can see that the smallest X or Y value is going to be turned into a 1, unless it's completely 0. So I think we need to add a little bit of a tolerance here. So we'll keep this here, but instead of always doing this, we'll just set it to this if our raw movement input.x is over a certain threshold. So we'll say mathf dot absolute value. That way it doesn't matter if we're moving left or right. And to this, we will pass raw movement input.x. And we'll say if this is greater than, let's say, 0.5f, then we want to do this. Else, we'll just set our normalized input x to 0. So norm input x equals 0. We can then do the same for our y input. If mathf.abs raw movement input.y is greater than 0.5f, then we want to set it to this. And then again, else normalized input y equals 0. And that should stop that from happening. So if we try with controller, we jump up, grab the wall, and if we just give X input, nothing happens until we move the stick far enough down. Then we'll start climbing or falling. Perfect, so now we have our wall slide, wall grab, and wall climb working. That means we've done everything that we needed to do for our touching wall state, and we're in the perfect position to move on to our wall jump state in the next episode. So yeah, that's going to do it for this episode. I hope you guys are excited to move forward with the wall jump. I certainly am. And so before I go, I would just like to give a huge thank you to all of my supporters and wonderful people over on Patreon, and a huge special thank you to Triac, Cody Lee, Pyro Says, and Miguel Gray for your support on Patreon. You guys are awesome, and I hope you guys all have a wonderful day.